All right, we just finished talking about glacial movement. We're going to get into glacial erosion. When a glacier moves, it'll pick up, pluck rock fragments and abrade them along the bottom. So drag it along the base of the glacier. Sometimes that will polish a glacier and you'll get this glacial polish. And other times, or at the same time, it'll striate and kind of leave these grooves in the rock. So you can tell the direction of the movement of the glacier, and this will produce a rock flour, a glacial flour, which is a very, very fine, powdery uh, um, sediment that helps to polish that surface, just like a polishing compound when you're polishing your car or some other thing that you might polish. Anyways, if you're hiking in the Sierra and you're high enough, you will see lots of evidence of this glacial polish, and it's a very, very reflective, smooth surface along that you'll find on the granite as you're hiking. So if you're ever up high hiking, take notice. Okay, so glaciers, when they erode or weather and erode, they will form these U-shaped valleys. So if you notice, what did I do with my mouse? Here we go. And let's get the cool little red thing going. But here we have a river forming a valley. And if you recall from when we talked about water and the way that rivers shape canyons, they're more V-shaped, very narrow at the bottom, and gradually get wider as we go higher. With a glacially carved valley, it's going to be more U-shaped. Right? And again, look in your book to see better detail of these diagrams, but this will show what we're going to be talking about in a little bit more detail. So we'll talk about cirques, horns, and arêtes here, but remember, glacial valleys are U-shaped, river valleys are V-shaped, and most glacial valleys are starting as river valleys. They get them started. So a cirque is basically where a glacier starts. It's a steep-sided half-bowl shaped recess that's carved into a mountain. It's the head of the glacial valley. You'll see these in the Sierra Nevada and any major mountain range. And then an arête is the sharp edge that separates two glacial valleys, so on either side of a cirque. And then if you happen to have three or more cirques that are around the top of a mountain, you will end up with a horn. All right, so right here, oops, grab the wrong mouse, we have an example of an arête. And over here, this is a horn that we can only see part of it. Top-down view would be good. When we're looking at more continental glaciation, we have a more rounded topography, and the weight and thickness of the continental ice produces more pronounced effects. You'll have rounded knobs, you'll have grooved or striated rock that's several meters deep and kilometers long, and it's thick enough to bury mountains, rounding off ridges and summits when we're dealing with this type of glaciation. We don't have any good examples out west here, but if you go out east, they're a lot more common. Over here, what's kind of cool, where I grew up in Pennsylvania, you'd find these a lot, up in New York, places like that. But you'll have these erratics, and these are big giant boulders that are carried by a glacier, and then when the glacier melts, it drops them there. So you have these random boulders that don't necessarily match the rock around them in odd places. And that's when the glaciers melted, they just drop big boulders. Okay, glacial till. This is just the general name for the unsorted material. It's unlayered. So all the glacial sediment, whether it's very, very fine to larger pieces of sediment, that falls under glacial till. It can be left behind at the sides and at the end of the glacier. Those are called lateral, medial, and end moraines, respectively. So we'll take a look at those and where we would find them. So lateral romaine lettuce. No, lateral moraines are elongated low mounds along the sides of the valley glacier. So all along and through here and on this side, and then we'd have them up here on this one as well. Medial remains are lateral moraines that are trapped between adjacent ice streams. So here we have these medial moraines in the middle. And then end moraines are at the end of the glacier. And those are ridges of till that are piled up in front of the glacier. Think of a bulldozer coming down and just piling up a mound of debris in front of it. And then recessional moraines are successive end moraines. And so we have, at one time, the glacier pushed up this material and created this end moraine right here. And then as the glacier receded, it pushed up another mound, and it's currently pushing up this mound right here. So those are recessional moraines. And then the ground moraine is a thin layer of till at the base of the glacier. And so that's just in that area also. Outwash is a sediment that's deposited by the large amounts of meltwater flowing over, beneath, and away from the ice at the end of the glacier. So it being a glacier, there's going to be meltwater, and there are rivers and streams that flow underneath that glacier and continue to weather and erode material from the end of the glacier. And depending on how steep it is and the velocity of the water will determine kind of what happens with these sediments. If it's relatively flat, you'll have a braided channel, which will have these braided drainages, and I believe we saw some of those when we were looking at water and erosion earlier this year. For the outwash, we'll have eskers, that's a sinuous ridge, kettles, glacial depression, and cames are low glacial mounds. So in this photograph here, we can see a little bit of all of these different things. So that low mound kettle is a depression there that's now filled in with water. They'll form these low ponds. And then glacial lakes and varves they're a lot like tree rings, and they'll form these layers, and when it's warmer, we'll have more water melting and flowing, and so these deposits will be thicker, and in the winter, or the color of the deposit will be thicker, and then in the winter time, when there isn't as much melting of water, you'll have these thinner lines generally, and so those will you can count the number of seasons based on the color and thicknesses of these lines, just like you can with a tree ring, and the different seasons, and count the years there. All right, so I'm not going to go into this. I'm going to leave it up to you for you guys to read the history on glaciers. Please read through it and know a little bit about it. I will probably have one or two questions on your quiz dealing with some historical information. But you can pause these and take a look at them, and obviously this information's all in your book. Okay, know about direct effects of past glaciations, the geomorphology, and the way that our country and the world in general looks a lot of times has been changed due to glaciers, and so knowing how. And we will still take a look at Yosemite and how that was formed by glaciers. And we have indirect effects. Be familiar with some of those. Lowering and rising of sea level. Again, at the very beginning of this presentation, in the first part, talked about how high the water would rise if all the ice in Antarctica melted. That would be pretty substantial. Know what a fjord is. Know about crustal rebound after the ice sheets melt. What happens? And you can be familiar with what a tillite is and read a little bit on that. So I'm going to put that information on you. I'll go back so you can read that, but you can always pause these. All right, so I hope that this helps. And again, ask questions if you have them.